Good evening, everyone, and welcome to Spindle TV. My name is Laney Shaughnessy. I'll be your host this evening. Thanks for joining me. Tonight, we're going to talk about some model slicing, and I want to apologize if the internet breaks up or if my microphone breaks up ahead of time. I had Cox come out, and apparently something's going on with my computer that's throttling things down. All my other devices are getting massive speeds, but the computer I work off of is not. So I have a new computer on its way, and it's not here yet. So we're going to have to grin and bear it through tonight's class. If it breaks up, somebody give me a shout out in the chat just to let me know, and we'll try to muscle through. All right. Tonight we're going to talk about some of the things you guys gave me a list last week of some of the things you'd like to see. And this evening we're going to talk about 3D model slicing. We're going to work with 3D model slicing. But before we do, I want to give a big shout out to everyone that's joined in. There's so many of you. Oh my goodness. Let's see here. Let's go from the top of the list. Joseph, good to see you. Crystal, good to see you. Roger, Ronnie, Dave, Rodney, Mike Smith, how you doing, buddy? Harvey, Steven, Camaro, what's happening? Mike Perry, Troy, Jason, Wayne, and I'm sure he's out there watching, my youngest YouTube watcher, Michael. How you doing tonight? Now, you guys and girls, there's a lot of things that make my day. And one of the things that make my day is last week while we were watching, or while we're trying to muscle through class and everything, Michael, my youngest viewer, was trying to show me his cool car. And I got so busy with the project and things, I didn't get to see it. And I was like, but fortunate for you and me, his mom and dad shared a video showing him trying to show me his new car, and also a picture so you can see how cool this car is. But I want you guys and girls to take a look at this and tell me if this is not the cutest thing that you have ever seen. And hopefully the audio picks up, because I think it's just cool as all be it. Michael, here's you trying to show me your car. It's a very cool car, buddy. Hopefully you're watching tonight. But let's take a look at, let's come over here and let's see if we can hear and watch Michael trying to show me his car. There's so many spikes and highs and lows and everything in there, even with the smoothing.
What are you showing him?
I'm trying to show my car.
Yeah? Your car?
Yeah, Tom, look at my car.
Shape to get the evil look at the body and everything.
Laney, look at my
if you're
car.
what I'm talking about, referring to that. I don't know if you guys and girls saw that, but here's Michael and his cool Lego car that him and his dad put together. Steven, way to go. Nice job on putting that car together. Michael, it's a very cool car. Hopefully you're having an awesome night. That video totally made my day. Hopefully the audio of the video came across as well. But Michael was in front of the TV trying to show me his car, and I got so tied up with teaching you guys and girls things that I didn't get to see it. I wasn't paying attention, Michael. So thanks for showing me the car. It's an awesome car. I wish I had one, because pretty cool stuff. All right. But that made my day. So thanks, Crystal and Steven, for sharing that video and photo with me. I greatly appreciate it. And once again, Michael, thanks for watching. And very cool car, buddy. Very cool car. All right. Had to get that out of the way. That made my day today. Let's see here. We are doing some model slicing. So let me get Vectric open. Let me get my resolution changed so you guys and girls can see all of that Good stuff. Let's see here. Let me get my model, or not my model resolution. Let me get my display resolution set properly, and we'll jump into this and get this motor rolling. Get this ball rolling. Get this cool Lego car rolling. Let's see here. What's my 12s? Ooh, doggy. All right. I say that every time I show that, change that resolution, because it just makes everything jump out of the screen. But now, Mom and Dad, y'all stay handy on the keyboard, because if Michael wants to tell me something, let me know, because I can't hear him. All right. Let's see here. What are we doing tonight? We are doing some slicing. Let's get over into our screen. Not that screen. We'll talk to this one for a minute. And I'm going to be working in Vectric VCarve Pro. Now, Desktop Pro and Aspire all have the capability of slicing a model. And typically when you're slicing a model, it's basically the idea of taking, whether it be a full 360-degree model, or, a model that has a lot of height or something to it, and literally slicing it like you're slicing an apple. And this is a stud finder. Look at it. Does it go off when it yeah, I thought so. Stud finder. All right. Dad joke. Okay. So slicing an object, depending on how thick you want your slices and pieces, slicing an object in multiple slices. After they're carved, you're stacking them together, gluing and reassembling them to create the full three-dimensional piece. It's a cool concept for those models that would kind of exceed your cutting height, or be able to do something on a flat CNC table that doesn't require a rotary axis and things like that. So what we're going to do is I'm going to set up a project, and the size of my project, especially the thickness of my material, is really going to determine the what my slice sizes are going to be, because I'd like to be able to cut each of these parts out of my material and then assemble them together with no waste or anything like that. Let me see where my camera went monochrome green on me. So in this case, for this particular model, this first model that I'm going to start with, it is a single-sided job, and it's going to be 12 inches by 12 inches. I'm just kind of going small. We could go big, right? Let's go a little bit bigger than 12 by 12. Let's go. I want to kind of keep it realistic, like I don't have to glue up panels and things like that. Now we'll keep it 12 by 12 for right now, and 3/4 of an inch thick. Now, I'm going to be touching off on the material surface for each of these parts that would get cut out on this project. We could work off the machine bed like I usually do all the time, but I'll work off the machine surface for this project. And for me, I'm going to start from the bottom left corner of the material. All right, so that's going to be our setup and everything. Let's see here. So let's go ahead and jump right in and click OK. Now, we're going to try to cover a couple of models. There's two models. Somebody asked, said, hey, can we do a nutcracker? So I actually have a nutcracker model. We'll give that a whirl. I kind of think a nutcracker model, when you see it later on in the class and all, I think that it would be a two-sided project, more so than a sliced model. But we can look at it both ways and, determine. We could probably do a combination of a two-sided model with slices, whatever. I don't know. But no, we wouldn't do that. But you wouldn't do that, by the way. A two-sided model with slices, you wouldn't do that. It'd be single-sided. So we'll look at it both ways. But let's get started with our first project of the evening. And it's going to be a grizzly bear. So I'm going to go into my modeling tab over here, guys. I had to get my thoughts there for a second. I'm going to import a 3D model. And I had a really cool alligator model that I wanted to try to do, but it's such a big file. It really bogs down the system. It's because it's huge. It really bogs down the system. And when I was working with it, practicing, playing around for tonight's class, it froze up my VCarve Pro in my system because there's something going on with my system. It froze it up and didn't let me really work with it. So we're going to not do it tonight. But one night I would like to try to look at it to see how we would slice that model to get the open mouth and everything and all that cool stuff. It's a pretty cool model. But yeah. Man, oh man, let me tell you, I had to drop a dime on a new computer. It was not cheap to get a nice, and I ended up going with a nice 3D gaming / streaming computer that really was built for that. And that's not your everyday Walmart or Best Buy computer, man, that I'm used to paying money for. We were encroaching go broke territory. But when after the speed tests and everything, and seeing what that my computer was really slowing down and stuff, I had to be able to keep and maintain a good, nice, clean video streams for you guys and all. I had no choice. All right, so let's get into a Z view here. So we're looking at this board head on, and you'll notice when my model came in, my model was facing kind of we're looking at the top of the bear head, right? So the first thing I have to do is orientate my model properly. And so I want the front, where the nose is, I want the front to come around and be facing us. So I want to come into the front, right? So it's facing us like that. And then I need to resize this model. Right now it's about 199 by 170 by 144 inches tall. It's a big old boy. My largest number here is 199, so I'll use that. That's my y-axis. So I'm going to go ahead and make that 11, right? So I know it because my board's 12 by 12, so I know 11 inches will fit on there, which will bring this to 11 by 9 and roughly 3/8 by almost 8 inches tall. So we'll apply that change to get this size down a bit. And we will center that model. Now, when we center the model, I want you to look at this. I'm going to turn this into the Y view so we can see the Z plane of my material. The Z plane is this black line right here. Well, my model has been split to where half the model is on above the Z plane and half the model is below it. And if I was doing a two-sided job, and I was bringing in a three-dimensional model and I needed to split it into a two-sided job, then hey, having the top and bottom would be great, right? But in this case, I'm doing a one-sided job, so I need to take and change the position of my Z-plane in the model. So I need to slide my Z-plane down, which is will put my model above the Z-plane, that line right there. And then I want to discard anything below that zero plane. Now, what this the discard does is, let's say that I wanted to cut some of this model off. I could literally put some of that material below the Z plane, not that much. Let's see here. Let's roughly go right about there. And when I click OK, it would cut off this lower half, right? And, you know, it would discard everything below that zero plane. Well, in this case, I don't want to discard anything. I want it on top of my zero plane. Okay, so any kind of model that you bring in, you want it on top of your zero plane for the most part. If it was a two-sided model, like you'll see when we create our nutcracker, then we'll end up creating both sides and not discarding below the zero plane, but you'll see that in a little bit. All right, let's click OK. Awesome blossom. All right. And here's our model. So if we look at that model straight on, like a Z view, this is kind of the view we're looking at, like if it's hanging on a wall or something. Let's take a look at it in the Y view, kind of get this looking at it from the side and everything. And the X view, we'll turn it around so we can see a little bit of the ears and features, all that wonderful jazz. Let's go in the X view, spin it around there, VCarve Pro. There you go. All right, now this model, from the bottom of the model to the very tippy top of the nose, is currently about 8 inches tall. Now, I have no problem working with an 8-inch tall piece if I'm going to slice this model up. You know, if I wanted to glue this up and have this 8-inch piece, you know, hanging on my wall or whatever, you know, kicks and giggles, then, you know, I have no problem slicing this up. But I actually want to kind of size the Z down. I want to shrink this down a bit. And I'm going to base it on how thick I want my slices and also how thick my material is. Now, notice that on this model here behind the ear, the router can't do undercuts, you know, on the neck here. The software has to build up some material because there's nothing on that, you know, under that material in this particular model itself. So we have this here that, you know, if this card, we may have to do some sculpting or a little bit of technical work to get some fur in there so it looks and blends nicely. But when we were looking at this from a front view, you wouldn't see any of that, right? We wouldn't see any of that and everything. Now, you guys and girls with me so far? Give me a thumbs up if you're with me so far. We've imported the 3D model, right? All right, smash that like button. Hit subscribe if you're not subscribed. That'd be cool too. All right, now, when it comes to, before I go to slice it, I actually want to, remember I said I wanted to size my model. So I'm going to go into my scale Z height of model tool here, and I want to set an exact height. And overall, my current model is about 8 inches, 7.947. Now, my pieces of material that I want to cut this model out of are going to be 3/4 of an inch thick. And so I want to use that to my advantage for my model slices and everything. And I'm going to say, okay, basically 0.75. And I'm going to multiply that by how many slices that I want. And in this case, I'm going to do it in 5 slices. So times 5, I'm going to hit equals. And that's going to give me an overall size of 3.75 inches. Now, I am actually going to change this to 3.74 to give myself about 10 thousandths of an inch of skin of material to play with, whether I put that skin at the top of the model or the material or the below the material. I'm just going to undersize it just a little bit, just by 10 thousandths of an inch, so that if any one of my boards are off a little bit, you know, and not quite 3/4, you know, I've got, it's 10 thousandths. It doesn't seem like much, but it really is in the schemes when it comes to accuracy. Okay, so 0.374 will be good for me. I'm going to click apply, and that is going to shrink down the Z height of this model. And if we tilt this model a little bit, it looks like a big old pile of, you know, just like a, you know, a big old mushy pile of nothing, you know, when you're looking at it at different views. It looks stubby and everything, but all in all, still from the front view, it's got a pretty cool outlook, right? And of course, again, I could keep it at the 8 inches. I don't have to, you know, sacrifice this. I could do more slices. You know, I could do, instead of 5, I could do 6 slices, 7 slices, whatever, however many slices it takes. But I'm going to do a nice even 5 slices. So each, I'm going to have 5 12 by 12 by 3/4 boards that I'm going to work with. And 1 or 2 of the slices, I'll probably, you know, get out of whole boards, but I might be able to fit 2 of the other slices and things on 1 board if I do a little bit of nesting, you know, on those 2 parts or something. Right? We'll find out. We can use our nesting tool in a moment to nest all of our parts out. But I'm going to click OK, because all we've done is scale the Z height right now to 3.74. And now I'm ready to slice and dice. So I've got my model here. I'm going to open up the slice tool. And in the slice tool, I have two options. Okay, I can automatically let it slice the models, and notice that it automatically took my material thickness and said, hey, you got a number of 5 slices, right? Total slice thickness is going to be 0.74 inches, you know, top slice. My top slice is not going to be 0.75, it's going to be 0.74. Give me that little 10,000th of an inch skin, right? So it'll automatically break it up. Now, if I want to be more specific and say, no, I want this in 3 slices, 4 slices, 5 slices, whatever, I can do that. If I want to do more boards, I could do that. But as I change these number of slices, it's going to change the thickness of my material, right? So I'm going to just let it automatically choose because I sized it for that particular reason, right? All right. So we're going to click the magic button and slice this model down. All right. Y'all still with me? Okay, I'm going to check in on you every once in a while. And I'm also going to keep a lookout in the, I keep having to look over my microphone so I can see the chat. I'm going to check out the chat. Let me move the microphone so I can see it every once in a while in case y'all have a question that pops up or anything. All right, so we're going to let this slice the model. And usually this is a really fast slice, but man, today, I tell you, my computer is bogging down. Let me close Michael's video here. And the picture that I showed you guys of that cool Lego car. Love that car. So the minimum amount of programs that I have open, the better in my case and everything right now, because the computer is throttled. Don't know why. I got everything turned off. I got Cortana turned off. I got everything turned off, but still some issues. All right. Now, notice, let's get back to a full view here. Notice that we now in our component tree in our modeling tab that we have 5 slices, and then we actually have still the original model. The original model that we sliced up, we can either turn that model off by unchecking it, or we could just delete it out of there. We really don't need it in there. It all depends on if you just want to kind of keep it on hand. Now, in my case, I'm just going to keep it on hand for class. So I'm going to uncheck that model. And now I have my individual slices. And let's tilt this a little bit to the side here so you can see if I turn off these slices one at a time. There goes the nose, the next slice, the next slice, the next slice, leaving me with my last slice, all that wonderful jazz, right? So slice 1 is basically going to be a majority. That's going to be the big piece here. Slice 2 is, you know, the next part of the head. Slice 3, and all these are out of 3/4 inch material. Slice 4 and slice 5. All right, to finish it off. And if we looked at these individually, just so you can see them, let's turn these off because we're going to be carving these out in individual boards. Let's turn off all the slices here. Slice number 1, that's slice number 1 there. Let's look at slice number 2 that's going to get cut out of a board. All right. Slice number 3. There we go. Slice number 4, board number 4, or however you want to call it. That'll be that. And then board number 5 is going to be just the tip of the nose. Now, slice number 4 and 5, I may be able to nest those two parts. The bottom part of the face, you know, which is this part here, and the nose, which is this part here. I may be able to, you know, nest these parts and have them on the same board, right? So I'm minimizing my material and not really wasting a big 12-inch by 12-inch board just for this small part, right? So we will take a look at that. And so let's put all of our slices back on here and all that jazz. One more. It's a bear with no neck. There we go. All right. Hey, Fred Grover, how you doing, bud? Thanks for joining us tonight. So now we've successfully sliced this model that otherwise, you know, on my CNC, it would be pretty close to pushing the limit of my Z height. I only have a maximum travel of 5 inches, right? Even if this was a 7-inch, if I left it at that 8 inches tall, I would just have more slices to deal with. All that good stuff. But I wanted to size it down a little bit just for to kind of show 5 slices. That's what I want to work with, 5 pieces of wood for this particular model, and you can do whatever you want to do. Now, just so you know, this bear model, it's a very cool model. Purchased this bear model off of CG Trader. I have no affiliation with CG Trader, cgtrader.com. But man, oh man, they have some beautiful models. They can range from, you know, $10 up to hundreds of dollars. This particular bear model here, I think it ran like $10, believe it or not. Very cool model. The alligator that I got today that I was going to show you guys, that was just too big of a file. It was a $40 model, and the Nutcracker was a $4 model, $3.95, right? Not that big of a deal. You know, sometimes you get what you pay for when it comes to CG Trader, you know, whether it's a high quality or low quality and things like that and stuff. So CG Trader is a pretty cool website. All right. I could have, you know, I have ZBrush for 3D sculpting and stuff. I got to sculpt this, but this would have taken me days and months. I think it actually, one bear that I did last month for a project, it took me a long time to get that done. I almost didn't get that project out in time for the subscribers of Spindle TV training. But this one here was on CG Trader, very inexpensive, and looks great, not bad. All right, so shout out to CG Trader for putting out some pretty cool models. Now, we've got some questions, right? Of course, how would you attach this to your table? Okay, Rodney, that's a good question. We're going to talk about that in a minute. Very good question. We're going to talk about that in just a second. Norm says, can the center be machined out? Can the center be machined out? The center of what? Help me understand what you mean by the center, Norm, and I'll answer that question. And then let's see here. Can you use a 3x2 board and do 3 of the slices? 3 foot by 2 foot? Or a 3x2, right? Design and science, 3x2, is that what you're talking about? And do 3 of the slices? Yeah, you can nest as many, you can nest your slices on your material, however big your piece is. I could do it out of one big piece, and I could have all my parts nested on there and cut them out all of one big piece if I wanted to, right? I don't have to cut it down to 12 by 12 sizes. I'm just using that board size for tonight's example. But if I wanted to carve this out of a big 12-inch by 40-inch board, I could cut all the slices out of that one board, right? And I could nest it. And not a problem. You just set up the board size, the material size to whatever size you want it to be. Yeah. And in my case, I'm just doing a 12 by 12, keeping things small. So even my mini carver users who have an 18 by 24 inch carving area can carve it. Cool. All right. The center part of the model where there's just a flat spot of the model and like a dish. I mean, yeah, you could mill that out, carve out the center of that flat area to create like a dish or a hiding spot if you wanted to make a, a hidden project where this thing was on hinges. You slid his head sideways, and there's a big old dish inside the neck where there's hidden goodies, candy and all kinds of neat stuff. Yeah, you could do that. But we are not going to machine the flat areas. We're going to actually create some vectors here in a second, so that we're just working with the model areas and keeping our runtime low. But yes, you could do that. Fred Grover, these models are not going to be available for you to download. That's why I mentioned CG Trader. I'm not going to give away models for free that are, for sale by another creator, another model artist that created this model, and take money out of his mouth and stuff. So go to cgtrader.com and type in bear model, and there's all kinds of hundreds of bears, and you'll see this one, all kinds of things. And like I said, it's somewhere around 10 to 20 bucks. And there you go. All right. Cool stuff. Okay, let's talk about our nesting tool. And just for kicks and giggles, let's change our board size for a minute. Let's say that I was doing a 24-inch long board, right? 12 inches wide, 24 inches long, and all that happy jazz, right? So I can nest a few of the parts on here and all that good stuff, right? Now, in my nesting tool, in my 2D view here, when each of those slices were created, I had it also create the vector boundaries for those models. When it sliced it, it created the vector boundaries for me. And that was when I was in the slicing tool. I had the option checked here to say create vector boundaries, right? So when it created those parts, it also created the vector boundaries. And we're going to utilize those vector boundaries here in just a moment. But first, let's go back to our drawing tab here. In our nesting tool, I'm going to be using we could use, in this case, an end mill to do some rough cutting, followed by a ball nose bit, of course, for our detail finish cut. I believe I'm going to do that because this is a pretty big model, cutting 3/4 of an inch. So I do want to hog away a lot of the waste material and all. So I'll just, for right now, say my tool clearance is going to be 1/4 of an inch, their diameter, my tool diameter. The clearance between the parts, I'm going to give myself a little bit of clearance. I'll go 1/4 inch. Border gap, how far I want to stay away from the border. 1/16 of an inch is fine for me. I can let the parts rotate for best fit here. Let's select those parts. Cool beans. I'm going to just nest from the bottom left corner over. And let's preview this. Okay, it's unable to nest the vectors and components at the same time. That's fine. I can understand that. I think I would need to, do I need to group them together? I forgot if I needed to group those together or not. Let me cancel this for a second. Let me see here. On my model and my vector, hold down your shift key. Can I group them together? Yeah, no, I can only group vectors together. Let me think. Can't group them together. So that's okay. I will turn off all the vectors. turn off those vectors. We won't group them right, or we won't nest them right now. We'll just keep them separate. And let's go back into our nesting tool. And I'm going to let them rotate up to 90 degrees for best fit and all that happy jazz. Let's see here. Let's preview that. Dun, 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 dun. Let's wait a second. What? Oh. I'm a goofball. I'm sitting there going, what is going on there? Let's take and close out of this tool for a minute. All right. Got to move. I was like, what the heck is going on there? Let's grab my model here. And I need to separate them, separate my slices. I was like, wait a minute, what's happening there? We'll just spread them out. Doom. 1, 2, 3, 4, and there we go. All right, my vector boundaries, each of these vector boundaries, let's move them to the side for a minute. I know there's a way to have the vector boundaries move with the part, but right now I can't think of what it is. Oh, my mind went a blank, you guys and girls. Let's move that over there. Okay, so let's grab all my models here, all my model parts. I don't need this vector boundary turned around yet. And let's nest them bad boys one more time, keeping the same parameters. Let's go ahead and preview that. And it might do this in 2 sheets. There was not enough room to work an area to nest all the components on a single sheet. The nest components has been assembled into groups. Okay, no problem. All right, so the nested components had to be assembled in 2 groups. Oh, let me see what it did to me here. 1. Okay. It's not breaking up the sheets. I understand what it's doing now. It's not showing me the second sheet. It's showing me the different group. This one model here is going to be on an individual board. And these other models here will be on the other board. So it broke it up into 2 groups, and it's not creating individual sheets like my vectors normally would and stuff like that. So I can respect and understand that. Way to go, Vectric. Not a problem. Not a problem. All right, so here's each of my parts. For right now, let me just get rid of these boundaries. There are so many things going on here, ladies and gentlemen. Okay. So basically, these 4 parts here were able to fit on this 12 by 24 inch board, and this other part could not fit. So therefore, it is on its own individual board and things. I can make my board a little bit longer so they all fit. Let's do that just so it's not so damn confusing. Excuse my language, Michael. Sorry, buddy. So it's not so darn confusing. Let's go, instead of 24 inches, I got a 40-inch cutting area. Let's go 36.5 inches. We'll go 36.5 inches. All because you guys asked if you could do it on multiple longer boards. All right. For me, it's easier to just cut my board down to 12 by 12, cut each one of those, 5 of them, and then mill each one of those, because I got to use 2-sided tape to hold these parts in. I'm not going to use tabs or anything. Somebody asked how you would hold this down and all that good stuff. I'm not going to be using tabs for these. We're going to put 2-sided tape on the back because when this thing gets milled, that 3D finish is going all the way down the side. Let's get into the 3D view here. It's got to mill all the way down to the side to mill that slice of that model to get all that detail. And it's going right down to my 3/4 inches. So during the finish cut, it's going to be cutting through the material. When it's finished cutting and stuff, and I need something holding that in place. So 2-sided tapes. Tabs are not going to cut it. You won't use tabs on this model. Okay. And everything. You're going to use 2-sided tape. So let's go back to our nesting here, and let's undo a few things. Undoing the nesting. Okay. And we can get rid of these boundaries. We'll draw those boundaries in a minute. Okay. So on our 5 parts, let's see if we can nest them bad boys so they all fit. Instead of a 90 degrees, I'm going to kind of let them twist and turn a little bit. Let's go with a 15-degree turn, up to 15 degrees, and let's do a preview to see if we can get all those parts to fit on the one board. There we go. All right. So just a small little turn, and all 5 of the parts can get cut out of one board. So there's all the pieces. Okay. I don't see how I could rearrange them to minimize my waste. I do have a bit of waste here, but with my spacing requirement needs and everything, I can't get this part to really fit in here. So I'll leave it. I'll go with the nesting that the program decided, which is all well and good. We'll do that. So I'm going to click OK. And all that happy jazz. Let's see here. If I select all of those, what's my overall size of that? 28 inches. So I could have got away with, instead of a 24-inch board, I could, got a lot of waste here. I'm going to resize my board down. Let's go 29 inches. Cool beans. All righty. Okay, with all them selected, let me see if I can get them centered up on my material. There we go. All right, so one more time, I'm going to ask you guys and girls, you still with me? So instead of a 12 by 12, I extended the board out so you guys could see all the parts, how they would get nested on a larger piece of material, right? So each one of these are going to get cut out of that one, in this case, 12 by 29-inch board now. I deleted those vector boundaries and stuff. We're going to recreate them now, and then we're going to move on. Before we do, boy, oh boy, something spiked a lot of questions here. So let's see here. Fred, okay. Lou says, how would you deal with undercuts? There are no undercuts. Your router cannot tilt and all and do undercuts and things, so you would deal with that by hand. And you would have to do some sculpting, but let's see here. All right, so if that model of the bear head is 8 inches tall, how many slices would have to be done, and how is it done using 3/4 inch thick boards? Fred? In this case, I've sized the board down to, I sized the model down to 3 inches. If this would have been done at the 8 inches, I believe it would take about, instead of 5 boards, I would say probably about 10 individual slices. Let's see here. Very quickly, create a new file. Let's go 29 by 12 by 3/4, keep things consistent. Model, import, model. Go into the bear. Bum, 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 dum, 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 dum. Orientate that to the front. Size that down to 11. Click apply. Center. Slide the 0 plane all the way down. Click OK. Slice the model that is 8 inches tall. 11 slices is how many slices that it would take at a 3/4 inch material. Each slice would be 3/4 of an inch. The very last slice would be about 0.4748 inches. Okay. All right. So 11 slices. All right. Back to where we were. Good question. Let's see here. Let's close that down. I don't need 2 VCarve Pros open. All right. Rodney, 3/4 inch plywood would look cool. All the fur and everything is going to be on the side edges of the material and all. Possibly could look cool. You know, all of this is going to get shaved down. So if we look at the 3D view here, imagine that this is the top of your plywood. The bottom of your plywood is the bottom part. All this is going to get shaved down. So you would have all those different layers of glue and your veneers and stuff. So yeah, it could probably have a pretty cool effect and everything. Yeah. Let's see here. Two-sided tape is awesome, right? It is awesome. That's what you would use. Can you use alignment pins? What would we use alignment pins for? You could create alignment pins if you wanted. You could drill how would you drill them on the backside? You'd be drilling them on the front, so you wouldn't have holes to drill on the back sides that would stick onto those pins. No, your alignment pins, I mean, you have your nice outline and everything where everything comes together and stuff. I wouldn't really see using alignment pins in this option, Jim, to be honest with you, because the alignment pins would be on the front parts, but not on the back. And where would I drill those holes on the back to make sure they stick correctly on the front, right? So no, I wouldn't see alignment pins as an option. Let's see here. Maybe a nice birch plywood. Yeah, with some stain. Let's see here. I would drill wooden dowels into the spoil board. Again, for what, Stephen? Drill wooden dowels for holding the individual parts so they don't move, because when these parts get cut out, it's cutting all the way through the material. So if you knew where the parts were, yeah, we could draw some holes in our vectors. We could draw a couple of holes here, very small dowel pins on the nose there, but we could draw holes or circles where our CNC could go and mill some holes in things so that we can stick dowels in there. But again, carving on the back side of these parts to get those holes perfectly drilled on the back side of these parts, we could do it as a two-sided job. So that answers that question. We could flip this whole thing over and drill our holes on the back side first, and then flip it back over and cut our parts out so we have a place to stick our dowels, because the holes have got to get drilled first, right? If you're going to use the dowel pins to hold these things from moving, that's an option, but it would be a two-sided job. So you're good thinking there. That could be an option, but two-sided tape is just as fine too. Either way, but yeah. And I think what Stephen is saying, guys and girls, is if I set this up as a two-sided job, if I were to set this up as a two-sided job, double-sided job here, and I had my parts nested like this, I could technically lay out, if I was going to use, let's say 1/4-inch dowel pins or 3/8 or whatever you want to be, I could technically lay out some alignment holes, however many you wanted, on these parts. I'm just throwing them here first. That's going to be kind of thin in there, so we'll go right about here. And I could take those dowel parts, now that I've got them kind of laid out where I wanted them, those alignment holes, I could move them to the other side, and on the back side here, I could do my drilling tool path. This drilling tool path would be in my waste board. It would be in my back of my board in this alignment, and in my waste board in this alignment. So I need to copy, instead of, let's undo, move, and copy them to the other side. Let's select those again. We need to copy them to the other side. Bear with me a second. Copy to the other side. And so on these holes here, just the holes, these holes on the front side here, these would be actually drilled into my waste board. Okay. So I touch off and zero off on my waste board, and I would, however deep, I'd probably have little half-inch dowels, quarter-inch into the wasteboard, quarter-inch up into the part. So quarter-inch, and this would be my wasteboard. Wasteboard. Lord have mercy. Turn the caps lock off. Wasteboard. Alignment. And this might work with what Jim was talking about too. Alignment pins. I think both Jim and Stephen were thinking on the same realm when it comes to alignment pins. We could hit select. And so those, if this was my wasteboard or my CNC, those would be milled into place. I'd stick my dowels in there, right, after the fact. I wouldn't stick the dowels in right this moment. Don't stick the dowels in right this moment. Then I would come in and I would, have the back side of my board face up, and I would drill these holes in the back side of the board. So again, quarter-inch deep. These holes would be back of board pins. Calculate that. I would run that toolpath on the back of the board. Then I would go over and stick the dowel pins in my, wasteboard and flip this board over, and stick it on the dowel pins. Clamp it down or whatever. And the thought, I guess, on this is using these pins to keep the part from moving if it's getting cut out. I would want to, definitely have 2 pins per part, because I don't want the part spinning or rotating either, right? And all that good stuff. So that would keep the part from moving, right? And all that good jazz. So we'd have a set of holes. It would be our top set here. That would be on our wasteboard. The bottom set would be in our back of our actual project board that we're cutting. We would stick that on those pins so it doesn't move, clamp it down, and then we'd be ready to machine our parts. And these alignment pins would keep things from moving, right? If they were tight enough and not sloppy and all that good stuff. So instead of double-sided tape. Because, if you were doing double-sided tape and I did 1, 2, 3, 4 or 5 strips, it could go through a lot of double-sided tape, right? The alignment pins is a good option for both Jim and Stephen that were thinking along those lines in our wasteboard and stuff, because as long as they don't poke through, right, and all that good stuff. But that would be a good option. It'd be a decent option. So, way to think outside the box, boys and girls. Okay. Let's see here. Answering some more questions. So if I'm thinking correctly, I would be using 5 different 3/4-inch boards for a different slice, correct? Fred, if you weren't doing it out of one board like I am here, 29 inches long by 12, where all 5 parts are getting cut out of that one board, then yes, you would be cutting out of 5 individual boards, each of those slices. That is correct. But in this case, we're doing out of a 129 long inch board. Each of the slices could fit on that board, and we can cut it out. So, but yes, if I would have left it 12 by 12, I would have had 5, technically 4, because 2 of the parts I could have fit on there on one of the boards. But I'd have 5 individual boards I'd be cutting it out of. All right, let's see here. He continued on, and then machine would stop for you to be able to change the wood blanks out, correct? Yeah, because you're saving 5 different tool paths. In that case, your rough cut and finish cut for each of those 5 individual boards. So yeah, at the end of each project, it would finish up, move that out, and you would start the next 2 tool paths on the next board and all. So, yep, exactly. What about your grain? Directions. parts on rotated instead of nesting them, rotated them yourself, and you would grain wouldn't matter, but the fur and all the detail that is into these models, it's not going to really be where it's flat and all on top of each other. You're not going to see that much of that and everything. You'd have to manually nest those parts if you wanted the grain in direction, or cut them out of individual pieces where the grain's all running in the same direction, right? On that 12 by 12 inch board. Okay, you're gonna have a class Thursday evening. When I sure am not. And Mike Nolan says the pen they were in the exact on every piece could help with the assembly. Could help with the assembly. Yeah. But so helping the parts in place. And design says dowels just to keep alignment when putting. Well, you guys are alignment when putting together. It was buffering. Okay, let's pause here for a second. Let's go test. Audio test 1, 2, 3. Can you guys and girls hear me? Am I still broken up? As far as the screen blurry, Mike, I'm not sure what that would be because the resolution, it's 1280 by 720. That's the best I could do for you guys and girls. If I kept it at 1920 by 1080 high res, then all the icons would be too small and you'd be squinting your eyes trying to see what I'm clicking on and everything. All right, let me make sure you guys can hear me. We can hear you, but the screen is a little bit blurry. I'm looking at the preview. Dun, dun, dun. Let's see here. Not sure what I can do about that. Guys and girls, I'm not sure what I can do about that. It's good now? Okay, so good. All right, let's get back onto these alignment pins. So you guys are talking about alignment pins for aligning the parts up and stuff. Yeah, you could do that. I could move this alignment pin down here. Or I could just have one alignment pin for, aligning the two parts together, or I could have two, whatever the case may be. And I could use those alignment pins to not only cut these holes in my wasteboard, and then on the back side, cut the matching mirrored holes in the board so they fit together. But I could, let me delete these two. Bear with me a second. Let's stay consistent. Let's copy those two to the other side. Okay. Having these drilled in the wasteboard, these holes, I could use pins to help. Again, when this board is clamped down on the table, those pins would be into the back of it from the wasteboard, keeping the parts from moving while they're getting cut out. That's an option. If two-sided tape is not an option for you, that alignment pins would work. These holes here, we could drill them a small amount into the parts, and even these holes on the back side, we could drill those in, or they're already drilled into the back side of the board. Never mind. We could drill these into the front side here of our board, and we could use them for alignment pins for aligning the parts if, you know, yeah, yes, all the way around. So keep it going. All right, now let's move on. All right, now when we're machining these parts and everything, I do not need to machine the flat regions. Let's go into our 3D view here. I do not need to machine these flat regions. These flat regions are the top of my board and all that wonderful jazz. All I need to have my bit doing to minimize my runtime and everything is machining the sides of this model all the way around. So we're going to create some vector boundaries and stuff. So I'm going to select, let me do this. Let me grab these alignment pins real quick and put them on a different layer so I can turn them off. So they're not, I've got them selected. I'm going to right click and move to a layer. And I'm just going to put this, my wasteboard / top of part, if you wanted to use it for aligning the parts when you're gluing it together. Pinholes. And I'll turn that off. Wonderful. All right. If we were to select our components here, we can go into our modeling tab and we can create our vector boundary. Okay. So that will create the vector boundary around each of the parts and everything. But I also want to create a boundary for my flat regions, these internal areas here. So I'm going to go into my 2D CAD side of the software, and I'm going to use my trace bitmap tool here. And in my trace bitmap tool on these parts, I'm going to use this grayscale image I'm going to use this grayscale image, and let's see if it won't. Will it let me do them all at one time? No. So that's all right. I'll do it one at a time. I'm going to use the color option, and I'm going to choose the white box because the white is the highest part of the model. Okay. So I'm going to choose the white box here, and you'll see that flat region, right, get filled in with red. And I'm going to be kind of loose with my vectors, be somewhat loose with them. So I'm going to go about halfway, and noise filter will go halfway with that as well. And we'll preview that to get that internal vector drawn. We'll click apply to lock that one in. Let's do this one here. Click that white box. Preview to create the vector and apply. This one here, check on the white box, preview and apply. And this one here, the white box, preview and apply. My nose, the top of my nose does not have a flat region. It's going to be the nose and nostril and everything. So I will not create a vector boundary for the internal boundary of that one. Okay, but all my other parts, I will. So now I have my internal and external boundaries. You guys and girls still with me on that? Okay, we've got our outer boundary and we have our inner boundary because we're not going to machine those flat areas. We're just going to work in between those two vectors, machining our sides of our material and everything because the top of our material is flat, right? Should be. So we're not going to machine those. That'd be a waste of time for our ball nose bit to have to go over that whole part when it can just work very quickly with the smaller parts. So y'all with me on that? All right. Now, I want to make sure that the bit that I'm going to be using, my ball nose bit, is able to get down the side of the part, to be able to machine down the side of the part and everything when it's machining and all. So I want to make sure that I offset. I want my bit to be able to go past this part just a little bit, about the diameter of the bit that I'm going to be using. I want it to be able to go past the model component, so I make sure it gets right down to the very bottom of those parts. That way I don't have any cleanup or really a whole lot of blending and cleanup to do when these parts are assembled together. So I'm going to take all my internal vectors for right now. Select this one, this one, this one, and this one. And I'm going to group them together. Okay, so that way I can turn them on and off together, right? And then I'm going to take my outer boundaries. They're already grouped together, so I don't need to do anything with that. But I'm going to offset them, use the offset tool. I'm going to offset those boundaries by the outward, by the diameter of the bit that I'm going to be using. And I'm going to be using an 1/8 inch tapered ball nose for this. I really don't see any need to use a 1/16 inch unless you just want to. But I'm going to use an 1/8 inch tapered ball nose. And so I'm going to offset out a little bit bigger than the ball nose that I'm using. So I'll go 0.15. I don't need sharp corners on that. I'm going to delete the original and select the new. So these boundaries here, when I create that offset, okay, it'll create those new outer vector boundaries. So my bit will be able to carve. The edge of my bit is going to bump up right against this vector. It's not going to go into my flat region. So it's going to be just working around this side here. And it's able to get down past the bottom and everything, so that I get all the detail all the way down to the bottom edge of my slice. All right, cool. All right, so now we're ready to do some machining. So for this, we're going to start out with a 3D rough cut. Okie dokie. And again, I'm going to now select all of my vectors. I'll use a 1/4 inch end mill for the rough cut to hog away the waste material, and I'm going to use the selected vectors as a boundary. I don't need to use a boundary offset because I've already offset that boundary manually there. I'm going to have it leave about 40 thousandths of an inch of skin. I don't want it going right down to the bottom of my model because I want these parts to still be kind of somewhat held in place until the finish cut starts, of course. And I'm going to do a Z level raster just to hog away a majority of that waste material. And I'll have it raster along the x-axis like a printer. All right, so we're going to, we'll do this bare model rough, and it's going to be a 0.25 end mill. Go ahead and name it just for good cause. Okay, we're going to hit select or calculate, not select, calculate. Now, I could change the parameters on my router bit to be a little bit more aggressive with the cut and everything, since I'm only working in these small areas, but I'll just leave my my setup the way it is. And so let's reset our preview, get rid of those holes. Look like Swiss cheese over there. Okay, so we can preview that visible toolpath. I could be a bit more aggressive with my toolpath and everything, so it takes less passes on the rough cut, because I believe I have this taken a 1/16 of an inch per pass, my 1/4 inch bit from the last class. Here, let me stop this. Let's stop that. Let me go in here and see what my bit is set up for. Yeah. Wrong. 0.1. Okay, let's go in here and let's choose. Dun-dun-dun-dun. I'm going to be just a little bit aggressive with my bit on this. I'll take 0.2 inches per pass. And let's recalculate that. And let's preview that. All right, let's see here. Will the end mill do the same? Go beyond like the ball nose? Well, we're using that selected vector. So the end mill is going to go beyond, but it's not going to go all the way down because we're leaving a 40,000ths of an inch skin allowance between the, the 3D rough cut and the 3D finish. So it's not going to cut all the way through the material. It's just going to remove a majority of that material, that waste material, and all, so that my finish bit doesn't have to work hard. Because remember, your finish toolpath does not do passes. Your finish toolpath rides at the full depth. So my bit is going to be riding at 3/4 of an inch until it gets, it raises up and down. But, for the most part, it is milling at that fullest depth. It does it in one pass. The finish cut is a one pass cut. So we have our rough cut here that's hogged away a majority of the waste material. Good. And now we're going to create our finish cut. Again, using the selected vectors as the boundary. No need for a boundary offset. I'm going to use my tapered ball nose bit, my 1/8 inch tapered ball nose bit. And I'm going to, in this case, I'm actually going to do an offset round and round. That'll be a little bit more optimized instead of trying to do a Z cut back and forth in these, between these small vectors. Allowing it to go around and around and around would be probably a little bit quicker and things like that. So I am going to do an offset cut for this and calculate that toolpath. This is going to be my air model finish cuts. And that was a 0.125 tapered. 0.125 tapered ball nose, TBN, tapered ball nose. And we'll calculate that out. And so that ball nose is going to be cutting between the inner vector and the outer vector. And because we offset that vector out by a little bit larger than the diameter of the bit, 0.15 was the number I used, that will make sure that bit gets all the way down to the bottom of that model. Okie dokie. Okie dokie. And so that is calculating out right now. Good. All right. While that is calculating, and by the way, designs and signs, I was answering your question as far as does the end mill do the same, go beyond like the ball nose bit will. Yes. And that's, it's going to carve between these two lines. I've only offset out 0.15 and I'm using a 1/4 inch end mill. So it's going to get majority of that, but it's not going to go all the way down because it can't fit between the model and that vector, but it's still going to go out to that vector line when it's machining and everything. All righty. So we'll let this calculate. And let's see, what do we got here? Did I answer? Hopefully. I'm looking forward to that new computer coming in so I don't have to deal with buffering and all that good stuff anymore. Yeah. All right, let's see here. Let me go back up here. Dowel pins we were talking about. How about dowel pins keep aligned when putting together, except for the very last piece of those. Except for the very last piece, of the nose. What about doing a through hole? Are you referring to doing a through hole straight through the material and into the wasteboard? I mean, that's an optional and everything, but that locks you into that project for that day, that time, that X and Y position. If you do holes in the wasteboard, then holes in the back of the board, you could, let's say that you're getting ready to start this project, but you had a rush emergency job came in and they're like, oh man, I got to get this cabinet done by tomorrow, but this bear is carving, right? You could literally, take this off, and you set up your project for your cabinet or whatever. And the XY changes, right? Well, we finished that cabinet job and now we can able to go back to our bear and all, and we go to put our board back on our dowel pins, but our XY has changed and we're not, it's going to be very hard, even with an automatic tool changer and all that stuff that you got, Steven, it's going to be very hard to kind of get back right where you are. Well, by doing it the other way, where you have holes on the back side, holes on the front side, you can drill your wasteboard. You can reset your X and Y somewhere on your table, re-drill new holes, drop it in, and now you're working off of that X and Y position instead of the one that you tried, created first thing in the morning before you had to get the cabinet job done. It's hard to explain, but I'm not a big fan of through holes. Long story short, try it, see how you like it. As long as you're doing it in one full run, no stops, don't stop, don't pass, don't collect $200, whatever, don't, you'll be fine, right? Why I would screw it down, because you aren't facing the top of the wood, are you? Well, Matt, no, not necessarily. I'm hoping that I've already surfaced my board and it's nice and flat and ready to carve before I get started and everything. But if I were surfacing it to make sure my board was nice and flat and then creating, bringing it down to 3/4 of an inch, let's say it was a little bigger, it was rough sawn wood or something, and I wanted to throw it on the table, surface it down, to 3/4, nice flat and everything on both sides, whatever, and then create the carving, then screws would be an issue. But yeah, you could screw it down because you're not really machining in those areas. But what about your last part? You can't put screws through the nose or anything. That kind of ruins it, right? So you have one part that you wouldn't be able to screw down. You'd have to think about that. But yeah, anything's possible. Let's see here. So Ron says I would use a 1/4 inch ball nose for the rough, right? You could do that, Ron. You could run a ball nose bit for the rough cut. Not a problem. You could use an end mill or a ball nose bit, either one. Not a problem at all. And if you were going to use a ball nose, you would have the option of, if you wanted to do that's the finished cut. Instead of just a Z-level raster, you could do a 3D raster, right? To hog away more of that material with that 1/4 inch ball nose. Either one option is good to go. Carl says, will you be cutting this in your shop? If you do, will you do a video? If I were to cut this project in my shop, I would absolutely do a video of it because it would be a cool project to film. Yes, I would. Rodney says, too many holes in the wasteboard gets confusing. That's true. That is true. Yeah. All right, let's get back to it now. So we've got our 3D finish calculated. Let's move over here. We've got our 3D finish calculated. Let's close this tool and open up our preview here. And so we could preview that cut. And so that ball nose bit is going to ride along. It's going to be a slow process here, but it's going to do that 3D cut, you know, all the way down to those parts. And then we would assemble them together, right? Okay. So I don't think we really need to watch the 3D finish toolpath cut out. I mean, we could, but I think we should move on. I think you guys know what a 3D finish cut looks like. Basically, if you don't, when the parts get cut, the sides are going to look like that. All right, but there's going to be wood around them. So I want to talk about our little nutcracker, right? Somebody mentioned a nutcracker last week, and I want to talk about that. So I'm going to come over here, and I should have done this early on. Save early, save often, guys. Don't follow my lead here, but I'm going to go ahead and save this. Let's go into CNC jobs, bear slice, and bear model project, and save that. Okay. We could watch the 3D finish, but I mean, even I could turn it down to a low resolution. So if anybody wants to see it, we can come back and see the 3D finish cut. But essentially, our ball nose is going to cut the parts out. All right. Let this save. And then we will move on to our nutcracker part. And on the nutcracker, it's a simple little model, a little wooden nutcracker. It's not a motion one where the back is open and the mouth moves and everything. So it's a fake nutcracker, if you will. But let's go ahead and close this project. And I'm going to go with I don't know, we'll go with a big nutcracker. I'll go with a 15-inch wide board. I could probably get that nutcracker out of a 7.5-inch wide piece, 15 by 7.5. I'm going to go 3/4. You could go thicker, right? Thicker material and all that good stuff, but I'm going to go 3/4. And I'm going to click OK. All righty. And once again, I'm going to go into the modeling tab. And I'm going to import a 3D component. We're going to go to CNC jobs, and let's go down to our nutcracker here, our nutcracker OBJ. All right. Once again, if I was looking at this in the Z view, we're not looking at the proper orientation of the nutcracker. Okay, so I need to orientate this properly. So I believe it's going to be my front. There you go. Or actually, I could go. Let me see here. Front. And let's rotate this part 90 degrees. There we go. All right, my board is 15 inches, so let's size this down to 14 and click apply, and then center that model. Now, if we look at this in the Y view, right, where this is split up and everything, and this model split into 2 halves, my overall model currently right now is 3.2146 inches, right? My overall model thickness and stuff. I could, adjust that down to where both halves, cut this out of a 3/4 inch board, and a 3/4 inch board would be 1.5 inches, or I could end up slicing this model into different parts and things, to assemble together, and all. But in this case, I really think it's a two-sided project more so than a one-sided project, because of the simple fact that if I try to bring this up above here, I have all of this dead wood right in here that the Vectric software is going to have to fill in. It can't just float up there. It's going to fill in with wood. And that's going to require me to have to do some of my own sculpting after this part is cut out and everything. So I'm going to center this model. And we could still do it out of a one-sided job, a one-sided board, we can do that. But I'm not going to discard anything that's below the zero plane, because the other half of my model is below the zero plane. But I am going to create both sides. Okay, and this job is set up as a single-sided job. So when I click OK, it's going to create both sides. All right, let's go back into a Z view here. And so we have our nutcracker top and bottom. Okay, these two halves. Let's turn off our top model here. So this is the top portion of that nutcracker. Let's turn that off. And this is the bottom portion, the other half, right? And I could carve both of those halves out of, two separate boards, right? Because this thing is, this particular model height currently right now, just this half a model height is 1.6 inches, so 1.5 inches thick. I have 3/4 inch material. I may need to slice this up to cut it out of the 3/4 inch material, or I could just cut it out of 1.5 inch material, resize this model height to 1.5 inches, and be good to go, and have it just cut out two parts and work with it. I sure hope the guy that asked about the nutcracker is here tonight, because I pulled this in just for him. All right, or for all of you, really, but just, all that good stuff. All right, so I will come into the Z height here, and my current slice, my model slice right here is 1.6069 inches. I'm going to just round that off and set an exact height of 1.5. Actually 1.49, just in case I want to carve it out of an 1.5 inch board, click apply. And click OK, or close that. Click OK. And then on the same thing on the top part, I'm going to go into the Z height of the model. Set that to 1.49 inches. Apply. Close that and click OK. All right, so let's look at our top view first. Now, the one thing that I'm, on the nutcracker, when cutting out, the one thing that I'm leery about is, let me get this thing spun around. Sorry, it's gotta regenerate. Is this thin little bill, this thin little slice, the hat's bill, right? The bill of the hat. It's a thin slice and all, and it would carve it and all that stuff, but it's going to be a very thin piece no matter what, no matter how I slice and dice it, right? If I don't slice it, or whatever. If I wanted to cut this out of two 1.5 inch thick boards, and then glue the two halves together, hey, great, I'm done, right? I could do that. But if I want to slice this, since we're talking about slicing, I could slice this model up, and it's going to, right now at 3/4 inch, because of the size that I set it, I got it set into two slices. And if I were to slice the model here, Okay. And that was the top. So I'm going to just add another level. I'm going to add another level here. And I'm going to rename this level top part, whatever. And I'll rename this level bottom part. Let's take our top part and our two slices, not the bottom part. Turn that one off. And I'm going to move them up to the top part. Okay, now I have my two slices. I don't need the actual model still checked. I could delete it out of there or just turn it off, turn off the visibility. So I have all right, bear with me. One, slice number one, and then slice number two. Now, slice number two, if we look at it alone, is going to be just those two little nubs and this part here. Okay, so again, two-sided tape or something, because those two little, the feet are going to get cut out, and you'll be gluing those on. So sometimes, you know, model slices and things can have little pieces and all that stuff. We want to try to minimize that as much as possible. But in this case, we can't because the legs. All right, now the bottom part here, let's go into our nutcracker bottom part. And that one's already been resized. Let's slice it into two slices. Slice that up. And Crystal, while this is calculating, Crystal asks, could you put that on a fourth axis? Just curious. Yes, you could put this on a fourth axis and do it. There are no undercuts to it. So as that's rotating, yeah, I believe you could do that on a fourth axis project. Yep. All right, so on our two slices up here that just got created, those two slices, that one and that one, they belong down in our bottom part level. And I'm going to turn off the main model. I don't need that nutcracker bottom turned on anymore because all I need is my two slices. And for this slice number one, is this part here, and slice number two is just that back part there. So and the this particular part here, the first piece was 3/4 inches of thick, slice one. The bottom piece is 0.73, a little less than 3/4, right? So, and then I could take all four of those slices that I cut out and assemble them together to create, or in this case, two slices to create the back half of the nutcracker. And then I could take the two slices from the front half of the nutcracker and put them together to create the front half, and then I could assemble both slices to create my full nutcracker. Now, this is if the job was set up as a single-sided job. Okay, if you're going to slice it, it has to be a single-sided job. If you're going to try to cut this out of a, let's say that I wanted my model overall height, 1.5 inches. 1.5 inches is 3 inches. If I had that kind of Z height, to, you know, put a 3-inch block on the table and cut 1.5 inches on one side, 1.5 inches on the other. Great. If I wanted my whole model to be just 1.5 inches, you know, that'd be a skinny nutcracker, but could do it. Either way, we could set this up as a 2-sided job to where it carves one whole side, flip the board over, it carves the whole other side, and then you do your profile cut to cut it out. But in this case, we're talking about slicing, so we're having it set up as a single-sided job, and we've got our different slices that are, you know, getting cut out. And again, on slice number 2 for the top part, the only fragile piece of this is going to be that little guy right there. That guy right there, the little bill of the hat. I believe that, you know, that thin piece, it's a breaking hazard, right? But still, you know, we could do it. So this is how we would slice this model. Now we would come in and create the tool path. Once again, the vector boundaries have been drawn for this. I'm going to go ahead and carve each of these slices. I could try to nest them. So I'm going to go ahead and get rid of my vector boundaries. Let's turn that off for a second. Okay. And let's start with our top slice first, slice number 1 or slice number 2. And let's move that over to here. Slice number 1. Let's move that over to here. For the size of my material and the size of this nutcracker, I'm not going to be able to nest these. Let me see. I might be lying to myself. I might be able to fit that in there. Okay, so we'll move that over here. All right, so we'll focus on one side at a time, or one board at a time here. So let's select this and go to our drawing tool and nest. And let's see here. I definitely want to use a small diameter end mill to be able to try to get my best in here, the best as possible, to cut this part out, you know. And also I'd probably be using a 1/16 inch tapered ball nose. So that tip diameter, let's go 0.0625. Full diameter, not tip diameter. The clearance between the parts, we'll go 1/8 of an inch. Border gap, 1/16 of an inch would be fine. Let it rotate a little bit so the parts fit in. I'll go with a 15 inch. You know, I can go from 0 to 90 or anything in between, right? I'll go with I'll let it turn 10 degrees instead of 15. Let's see what 10 degrees does. I don't want to mirror the parts for best fit, and I do not want to allow parts inside of other parts because there's no parts inside of other parts for this one. So we will click preview, and let's see if these two parts nest. There was not enough room in the work area you know, to put on a single sheet, so it did it in 2 sheets. And of course, it's not going to show the 2 sheets. It's going to just show the 2 groups. It's not going to show the individual sheets and all, like a part fit. And the funny thing is what are my feet doing way out here? What are those little nubs doing? They're not even on the board. What's up with that, Junior? Yeah, I'm not going to try to nest these parts. I'm just going to cut them out of individual pieces. No nesting. So let's undo that. All right. So I'm going to undo my move and my move. Okay. And I'm going to create the vectors for each of these levels here, each of these slices. I'm going to just stick with 4 pieces of wood, 2 slices for each part. The parts are almost all of them are 3/4 of an inch thick, except for the top piece is about 0.73 inches thick. So I'm not even going to try to nest these things in and everything. So let's focus on one part at a time. Let's go with slice number 1 for the top piece. All right, let's create a vector boundary around that. Okay. And on this particular part here, turn off slice number 1. On sorry, I had them both selected. When you have them both selected, when you check and uncheck it, it checks both of them. Let me get off of here. All right, there we go. Turn off slice number 2 for a minute. All right, once again, the white areas are the flat regions of this piece. So I don't need to machine the flat regions. So I'm going to go into my drawing tab, my trace bitmap tool. I'm going to select the white areas. I'm going to be a little loose with the corner fit noise filter. I'll turn that about halfway as well. And let's preview that. Click apply, close. So I'll have that inside vectors as well. All right, so I've got my outside vectors and my inside vectors for slice number 1. Cool. All right, now I'm going to take all of these and I'm going to actually break these up into layers where it has slice 1 and slice 2 for both the bottom and the top are on there. But I'm going to come in and add 2 more layers. And I'm going to call this bottom slice 1. Bottom slice 2. And on these, I'm going to rename them top slice 2 and top slice 1. And we're almost done here. Rename that. Top slice 1. I can go ahead and turn off these other layers. They don't need to be on. All right, coming back over here in my modeling tab, I only have slice 1 for the top on and active. So I'm going to select all of these vectors and everything, and I'm going to move them to top slice number 1, right? Get them moved over there. Cool. Now I can come in and turn that layer off to hide it. Uncheck this, turn on slice number 2. Slice number 2, I'm going to go ahead and create the vector boundary for it. Slice number 2 does not have any internal flat spots, right? Because it's the top of my part. So I don't have any internal vectors. I just have the external. And of course, when you're creating your vectors, make sure that you have the right layer active. Cool beans. Let's create that vector boundary again. There we go. And so now both of these, I want to make sure that they're moved over to slice number 2, which they are. Great. Good job. All that wonderful stuff. And now I can turn that off. All right, bottom slice number 1. Let's turn that on. Let's come over here. Get to the bottom parts. Slice number 1. And notice that nothing's showing up. That's because the bottom part of the model is on another layer. Most likely it's on the Nutcracker bottom layer, right? So if I turn this on, I'm not seeing it. If I turn this on, I'm not seeing it. So most likely it's right there. It is right there. all that wonderful jazz. So let's first of all get these things separated. So let me see. The case of the missing nutcracker model. Where is that at? Where is it at? I bet you it's right in here. Not that one, this one. Slice number 1. It's probably hiding under the other model. Let me look at this. Yep. That be the back of it. That's the back of it. That's not the front. The front looks like this. Is it going to let me turn on the front? The front looks like that. Has a little bit higher skirt right here, and it's got the bill, right? And the bottom part looks like this. Almost looks identical, but it doesn't have that bill, right? That's the bottom part. So I need that bottom part, this guy, just the model, the bottom part. I need that moved to bottom slice 1. Let's move it over there. Excellent. All right. So we can turn that off. And now if I come to bottom slice 1, here's my part. Now, these internal vectors for bottom slice 1 don't need to be there. And they don't belong there. They belong here. So I got to move these back. Bear with me a second, ladies and gentlemen. Get my layers confused here. So top slice, let's turn everything off. Top slice number 1 should be my internal and external vectors, right? Here, let's do this. Why be a pain in the ass? Let's turn this, let's delete all the vectors. We'll do them in a minute once we get them separated, right? Why be a pain in the butt? Get all the vectors, delete those out. Okay. Let's turn on slice number 2 and get it on its appropriate layer. Why are we trying to be so confusing? That layer is right here. Let's move that to bottom slice 2. Okay. All right. So now if I turn on all my models, and stuff, I should be able to go top slice number 1, right? That's, and of course they all look right here, but in this, I'm looking in the 2D view. Top slice number 1, that's him. Top slice number 2, that's him. Bottom slice number 1, that's him. And bottom slice number 2, that's him. Wonderful. Now I can come in here one at a time. This is top slice number 1, slice number 1, create my vector boundaries, make sure that the layer is active, slice number 1, boom. Okay, got the vector boundary. While I'm in this layer and everything, I'm going to go over to my drawing tab and I'm going to do my little trace bitmap on the internal, click apply, great, okay, boom. All right, slice number 1 is done. Move that, turn on slice number 2. In our modeling tab, we just need to create the vector boundary, the outside boundary. And look what I did. When I created slice number 2, I was still in slice number 1 up here, so it opened up slice number 1. So I'm going to Control Z. I'm going to undo that. And make sure that the layer you're working in is active. Select it in bold. All right, so that way when I come in here and create the vector boundary, it creates it on the appropriate layer, right? All right, slice number 1 for the bottom. Make sure it's active. Make sure that layer is active. We're going to come over here to slice number 1. We're going to create the vector boundary. Excellent. And again, this one has a flat region, so we'll go to our drawing tab, select our white, and preview apply. Close that. Now we've got our internal. Same thing we did with the bear, just with a nutcracker, right? All right, so turn that off. Slice number 2, bottom slice number 2. Let's go back to our model. Slice number 2 here and create our vector boundary. Wonderful. That's done. Okay, so now we have all of our individual model components all broken up into 4 separate layers. Okay, now I'm going to come into here, and now I'm ready to create some tool pathing. We got 4 different slices, 4 different finish cuts, 4 different rough cuts, right? So this is slice number 1 for the top piece. I'm going to select everything. I don't necessarily need to collect everything, but I'm selecting my boundaries here. We're going to do a 3D rough cut. Could you add a tab to make the bill of the hat thicker? Yeah, Harvey. So Harvey asked a good question. He's like, could you add a tab to make the bill of the hat thicker? And what Harvey is talking about is in our clip art. Let's go to our clip art here. Under clip art, you're going to have some audio issues. Hold on a minute. All right. Let me know if my audio is broken up or not. But what Harvey's talking about is in our 3D view, and let me move his comment out of the way. In our clip art, there's different tabs that you could, drop in, and you could use those tabs to make actual material, right? So he's referring to, we could probably use the rectangular tab here, and we could drop it in and make that bill thicker on the hat. We sure could do that. I'm not going to do that right now, but we could absolutely do that for sure. Okay. We could absolutely do that. All right. Now, on my model, back to my model parts here, modeling tab, all 4 of my models, top and bottom, are turned on, and therefore it's giving me an error in my material thickness. I need to work with one section at a time, and one slice at a time, just like I'm working with that one layer. So let's turn off the bottom right now, and let's turn off slice number 2 so that I don't have an error, right? Okay. So 3D rough cut, I'm going to use the selected vectors, 1/4 inch end mill. You could use a ball nose, whatever you want. And I'm going to use the selected vectors as the boundary. Now, I want my bit, once again, to be able to get all the way down to the bottom. And so I need to do the offset for this outside vector boundary. I'm going to offset this outward so that my ball nose bit can do some good work all the way down the side, just like we did with the bear. So that's actually the next step before the tool pathing. Let's go back over to our drawing tab here. And slice number 1 for the top, our outside boundary. We're going to offset that outward. And again, I'm going to use a 1/16 inch tapered ball nose. So instead of 0.06, I'll go 0.0625. I'm going to go 0.07. That'll be good. And delete the original, select the new, and I'm going to offset that. Okay. So that one's done. Let's come in and turn off slice number 1. Turn on slice number 2. This boundary here, all I need is the boundary. I don't need the model present. So offset outward 0.07 to create. And of course, when you do that, but though, make sure the right layer is active. Boom. Make sure layer 2 is there active. All right, we'll offset that one. That'll be good. See here, bottom slice number 1. Make sure it's active. That outside vector, we're going to offset that outward. Delete the original. Boom. And slice number 2. Make sure it's active. Bold means active. On. And you should be able to read it up here. Offset that outward. Delete the original. Okie dokie. Now let's get back to tool pathing. Bum, 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 bum. Okay, so once again, 3D rough cut. Can use the selected vectors as the boundary. 1/4 inch end mill is fine. I could use an 1/8 inch if I want to, but 1/4 inch is fine. And you could use a ball nose, right? Or an end mill. Either one. I'm using an end mill. I'm going to rough cut this just to hog away some of that waste material. And again, Blue Knight says, can this be done out of one piece of wood side by side? Yes, it could be done out of one piece of wood. If I made my wood long enough, I could do it out of one piece of wood. Long enough and wide enough, I could carve all 4 parts out of that one piece of wood, one-sided, just like we did with the bear. Absolutely. Yep. But in this case, I'm doing one board at a time, one slice at a time. Okay. All right. Let's see here. So we got our rough cut. In this case, we're going to go with the 3D finish. I'm going to use my 1/16 inch tapered ball nose. Using the selected vectors once again as the boundary. I'm going to offset cut. I think that'll be, I could actually on this one, I could raster cut it with the grain rather than offset it. Raster cut it, yeah. Let me see here. It's going to try to raster cut between these vectors like this rather than go around and around and around. I'm going to offset it. I'll offset it. I'm usually not a big fan of offsetting, but this one, these sliced models call for it. So this is board 1, slice 1, right? I don't know. Nutcracker. 0.25 end mill. Calculate. Sixteenth inch tapered ball nose, offset cutting around and around, cutting between the vectors. Yeah. Okay. Let that calculate out. If you guys and girls, now's the time. If you have any questions, let me know, because as soon as these 4 things are finished calculating, we are calling it a night. Okay. So if you have questions, now's the time to ask them in the chat. So, because as soon as these 4 slices get calculated, these 4 tool paths, rough and finish cuts, we're going to say good night. Lou says, I hate it when that happens. What do you hate when what happens, Lou? Let me know. Let me know. Almost done with that calculation. The two main slices for each side will probably be, the worst. All right, so just for kicks and giggles, I'm going to turn my preview simulation quality down, and let's preview the visible toolpath. So we would have a rough cut, hogging away our waste material, and then that would be followed up with a 16th inch tapered ball nose cut. And again, this is not a mechanical nutcracker where it has the little lever on the back and the mouth opening and all that stuff. Sure you can make one of those, but we are not doing that in this right now. This is just a regular old nutcracker. All right. And so that would be the first piece there. Good on you. All right, and so slice number 1, we'll turn that off, turn on slice number 2, and come over here into our models and turn on slice number 2 model. Make sure your model's on too when you're calculating your toolpath. Let's see here. Let's do this. Let's rename this so we know what it is. Board 81. Slice 1 nutcracker, and this one is actually the 0.25 end mill. This one is my finish cut. I don't know why I named it that way. Let's rename this. This is the 0.0625 TBN, tapered ball nose. Okay, so that's that. All right. In here for slice number 2, we're going to create our 3D rough cut. Select our vectors. End mill 4/1000ths, using the selected vectors as the boundary. This is board 2. Slice 2, right? Top slice 2, whatever you want to call it. Top slice, right? 2. And this is going to be the 0.25 end mill. Calculate that toolpath. Michael wants you to do a video with him in our shop. We could do that, Michael. We could set that up, buddy. I'll come down and what do you want to make? We'll make it. But your mom and dad got to give me permission to use their cool CNC machine. But yeah, we can do that for sure. I wouldn't mind making a run down there and doing that. Let's see here. I can see putting a pin in the hat and have this swing open to reveal a compartment in the belly area. There you go. All right, good for you. All right, let's reset this preview and go back to the 2D view. So Rodney's got ideas of making a compartment in the belly area. Pretty cool. Let's see here. We're going to do our 3D finish cut. Let's make this active, right? That's our active layer. It's not necessary, but still. 16th inch tapered ball nose, selected vector is the boundary. Going to do an offset cut. This is board 2. Top slice 2. And this is my 0.0625 tapered ball nose. And we could calculate that. and let that calculate out. And we would rinse and repeat for the other two parts, right? Let's see here. Ronnie Probert. Ronnie Probert, you always ask the run time. He's like, how long is it going to take to run that? All right. So while this is calculating, let me go in and let's find out. Ronnie, let's go into. I like Ronnie. He's always like, hey, how long will that run? How long will that run? Let's find out. Let's go into the Vectric carve Pro 10.5. I don't know why I did that when I could have just right-clicked on the icon and opened up a new one, but that's okay. So Ronnie, we're going to find out here in just a second. Let me open that project back up, which is going to be the open an existing project from CNC Jobs, Bear Slice, Bear Project. Let that open up while this is calculating. Let's see here. Exo lands. Anytime when you like. Yeah, man. I'm all up for young woodworkers working with them in the shop. So for sure, we can set that up. Yeah. Yeah, we can when we're talking about your rotary project later on, we can talk about that. Okay, so the board 1 and board 2. This is our our top piece, basically the 3D rough and 3D finish cut for that part, right? And the finish cut is going to be cutting when it cuts all the way down. It's cutting all the way down to the bottom. So again, two-sided tape to hold these pieces in, or you guys can get into the alignment pin thing and all that good stuff if you wanted to on this small thing. For this small project, two-sided tape would be more applicable. When that ball nose bit comes through and cuts on these edges, that's why you don't see me creating a profile cut. It's not going to be necessary. This part's going to be cutting all the way down and out from that model, and there's going to be nothing left on the sides, so that part will just come right up. So we want to make sure that you're securing that. There's not going to be any tabs on this. Two-sided tape would be ideal and everything and all that happy jazz. Okay. While that is running out, let's take a quick peek at our wasteboard alignment pins. I didn't create the toolpath for the pins on the back side, but board rough cut and finish cut, rough cut and finish cut. If we look at our time on our Bear model, about an hour for the rough cutting and about 4 hours for the finish cutting on that part. Ronnie Probert. So about a 5-hour job to cut out that 5-inch tall bear by 11 inches around. All those slices or all those parts. All right, cool beans. All right, so we have our finish cut. Wonderful. All right, and again, like I said, rinse and repeat. We would turn that off, turn on our bottom slice number 1 vectors, make sure it's active. Come over here and turn off our top part, turn on our bottom part, and just deal with slice number 1, one slice at a time. We want to create that toolpath on. Select our vectors, create the rough cut. Nothing changes here, so I'm just going to, board 3, bottom, slice 1, 0.25 in mill. Calculate that toolpath. Okay. then create the finish cut toolpath, and then do bottom slice 2, and you're done. Okay, so let's close back to this, close here, turn off slice number 1, turn on slice number, oh wait, no, I'm sorry, we just did the rough cut. I got to do the finish cut. Leave slice number 1 turned on. 3D finish cut, 16th inch tapered ball nose. Again, this is board 3, slice 1, finish cut. And 0.0625 tapered ball nose. Calculate it out. Okay. And then when that's done, do the last one, and we're going to be good to go. All right. Any other questions? Any other questions? Because we're wrapping this up. I appreciate you. Thanks, Mike. I appreciate you. Thanks, CB, Harvey, and Rodney for the thumbs up. I don't think I missed any of the questions. Let me just take a quick gander. Jim Starnes, watching from Southeast South Dakota. Welcome. Rodney, I have too many holes on the wasteboard. Guys are talking about waste holes in the wasteboard or holes in the wasteboard. Wood putty. Somebody fills their holes with wood putty. Hey, Crisscross Crafts. I didn't even see you pop in. How you doing? Guys and girls, welcome, Chris. If you haven't got a chance, definitely go check out Chris's channel on YouTube. He makes some good stuff over there. Crisscross Crafts, right, on YouTube. Once again, Crisscross Crafts on YouTube. Check it out. He makes some good stuff. How you doing, bud? Hopefully you're still there. You might have popped in and out because you got a life. None of us else did. I'm just kidding. We all have lives. But thank you guys for taking time out of your life to spend with me on Tuesday nights with these long classes. I know some of them can get tedious and boring, but you know, we try to pack in probably too much information in one class, but try to get, you know, at least a project or two kind of just to show some different varieties in things, and that can extend these out, right? But hopefully you're learning something and picking something up in these, and all that good stuff. But I really do, I do really sincerely appreciate each and every one of you for coming and spending your Tuesday evenings with me, hanging out. Michael, appreciate you staying up past your bedtime and hanging out with me and watching videos, buddy. He's probably passed out by now. I get boring after a while. Kids fall asleep tend to. But all right, so that was what was that? That was our finish cut. So that one's done. We don't need to preview it. We know what it looks like. Slice number 2. Let's turn that model on and come over here. Turn this off. Bottom slice number 2. Boom. And once again, select our vectors. Make sure that's active. Rough cut, nothing changes here. This is going to be board 4, final board 4. So BD4, slice 2. I'll call it rough just for now. Don't really need to. I can just put the bit in there and I know it's a rough cut just by the bit. Rough, 0.25 in mil, calculate. And then our finish cut. Let's see here. When you lose a layer, wait, hold on. Oh, lose, like that sucks when you lose a layer. Yes, when you lose things in a layer, like, and it's like, okay, where did everything go? When I was hunting and searching for those models, see, the software automatically broke it up into its individual layers, like top and bottom. When I imported that model, it created those layers, top and bottom layers, and it put all the top parts in there, and then the bottom parts. But then I took it a step further and I sliced them Well, both slices were on, the top and both slices were on the bottom, and I had to separate them, but I lost that one. I was like, where is it at? So it was all confusing and during that short little spurt of time. All right, so the rough cut is finished. We're going to create our finished tool path. Rinse and repeat. 16th inch tapered ball nose, selected vector as the boundary, offset, and we're going to name this one board 4, slice 2, finish. I'll just throw that in there. And it is the 0.0625 TBN, tapered ball nose. And that's it, guys and girls. Calculate that out. Don't forget, notice again, I didn't save the work, right? Save early, save often. Don't follow my example on that one. Everything else follow my example, but not that. Try to save early and save often as you're going through, because of power outages or things like that. What would happen right now after all this if my VCarve Pro decided to freeze up and close down just because I overtaxed it or whatever? Then all of that work, it's gone, right? I'd be sitting here going, oh, well, I'm not doing the nutcracker right now. But what I want to do, as soon as this is finished calculating, immediately I want to jump over and save the project. We should have done that first and foremost. You guys and girls do that. Save your projects first and then focus on your toolpaths, right? Saving them and all. So this is almost finished calculating. There we go. And before we do anything further, we're going to come over to Save As on the File menu to save our design, right? Save our design. So we're going to go to CNC Jobs, Nutcracker. That's the model. So I'll go in here and I'll just call this Nutcracker. Cracker slice design. Save that. And let that save. Look at there, not responding. It could freeze up on me. I could lose everything. Oh no, it's not. It's just taking a minute because it's a big model. What's the name of the website where you can get models? CG Charlie Golf, right? CG Trader, 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 like, wood trader, right? CGtrader.com. CGtrader.com. Turbo Squid, CGtrader.com. Thingiverse, there's all kinds of things, but I like CGtrader.com. They got some nice models and everything. And, for models like this, when we're talking about slicing and what was the other model I did a class on? I buy the models for the classes and stuff. So, because they got some cool models from time to time. All right. So our last piece is calculated and all that wonderful jazz. The rough cut and finish cut. We are finished. Let's see here. CGtrader.com was the answer to that question. Great class. Good night to all. Good night, Laney. Thank you. Juan, thanks from, Arizona, right? Tan Valley. Cool. Santan Valley, not Tan Valley. Probably get a tan up there, right? It's hot enough. All right. Until next time, ladies and gentlemen, and Michael, time for bed. No, I'm just kidding. Have a good night, bud. Until next time, I'll see you soon. Bye now.